There are a couple of methods and debate regarding modeling of transactions. We will discuss each of them. I will also share my favorite and the reason behind it, but depends on your modeling requirement, then you would decide which is the best fit for your organization. So the first idea is that the events are all intersections of business data and so should be modeled as the links. So let's get understanding how it is worked. Think about that there is an ice cream shop across your street and you go there and to buy vanilla chocolate ice cream. So this action creates different entities in the database of this big ice cream company. We have customer, store and product entities take place, and the interaction between them, there is a sales transaction is happening. So according to first rule, we know that we should model transaction as links. So we created 3 hubs for customer, product and store, and a link table for the sales event, which include all foreign key columns from the relevant hubs, and as well as the mandatory columns as record source and the load date. And we also have some additional information like the invoice date as when you bought the ice cream or the price information. So there are the characteristics of the sales event. So we create a satellite table which hangs on the link table and put all these attributes in there. So remember that we can either connect the satellite to the hub or the link, and in this scenario our satellite is connected to the link table. So when the first time when you buy the ice cream, all relevant information about you as a customer and the product you bought vanilla chocolate ice cream and store information is inserted in the data vault tables. So far so good. But then you became a loyal customer of the store and almost every day after the lunch break you buy a vanilla chocolate ice cream. So it means that more than one transaction for the same customer, for the same product and the store is happening. So look at how it impacts our data vault table. So customer information is here and store is already here and the product vanilla chocolate is already there. But where is the information about the replicated sales events that we are doing every day? So as we know that we use the link table to model transactions, but it only represents the first time that intersection of the keys is seen by the data vault. So if the same set of associated keys arrives again, it will be ignored by the data warehouse. So there will be no additional records will take place in the link table for the following sales transactions. So this means that the data warehouse can lose the transactions. But you may think that we have a satellite table and satellite store history, so maybe we can use it for replicated sales transaction. But this is a tricky part because satellites store the history when there is an update in the characteristics of a business key or a relationship. When we consider our scenario as satellite is hanged on the link, replicated transaction is not change or update for the relationship. It is simply a new record and every record has its own descriptive attributes, and additionally, transactions never change and cannot be updated. Okay, what does it mean? So think about that you bought a t-shirt from the Amazon and then you tried it and you didn't like the color and you want to change it with the red t-shirt. So you cannot just simply update the color of your product which is already invoiced. So the only way you need to return the product, pay a change fee if required, and shop owners need to cancel your sales and they create new order for you. Or think about another example. So you bought a flight ticket from Madrid to Rome. Then you decided to change your travel destination. So you want to fly to Florence for a historical adventure. But you cannot update the target destination of your purchase because the transaction is already finalized. So you need to cancel your ticket first and bought a new one. Therefore, updating the old invoice is not possible without creating a new invoice. And if a transaction needs to be cancelled, a reverse transaction has to be created in the source system and loaded into non-historized link. So now we are clear that we are not able to update transaction data and store historical changes about them. So we saw that the standard link was not useful for us to modeling the transactions. So maybe we need to do some kind of changes in the structure of the link that will be helpful for us. So the first methodology we use to model transactions or sensor data is the usage of the non-historized links, and they're also known as transactional links. So we simply insert the identifier key from the source table that makes our sales unique. In this scenario, we can assume that sales ID uniquely defined each transaction and will be inserted into the non-historized link. And this identifier, which make your transaction unique, can also be a composite attribute. So look at the main elements of the transactional link. So similar to standard link, we have the hashed foreign keys from the reference hubs and also load date and the record source column. Different from the standard link, we have the sales ID. This will be the data about the transaction itself. We also refer to degenerated keys or dependent child key. The main characteristics of the dependent child key is it is used as an identifier in the link structure. This field does not have any meaning without combination of the business keys. So mostly we need dependent child key in this kind of scenarios where the transaction is repeated for the same business key intersections and needs to be uniquely identified. And additionally, we may store the attributes like amount, type, date that are the part of the transactions directly into the non-historized link, or we could split them into a satellite table. For example, in our scenario, it will be the invoice date that shows when the purchase has done and also the price information of the product. And finally, we have the hash key column that represents the primary key value. And if a dependent child key is present in a link structure, then a hash key in the link is generated from that dependent child key and the reference hub business keys. So now we have a transactional link table that includes the unique transaction information and a connected satellite that contains all descriptive attributes such as invoice date and the price. It is also design preferences, but in most cases we should avoid to add attributes of transaction directly into the link table instead of using the satellite structure, because the attributes in link table increases the complexity of the model and the maintenance cost. Additionally, it makes more complicated to load non-historized link tables. And one major point is that because transactions cannot be updated, the characteristics of them will not also be changed. For example, you cannot change price of a transaction which already take place, or you cannot also change the time when the transaction is happened. So these descriptions cannot be updated or cannot change. Therefore, the satellite table hang on the non-historized table include the one-to-one description of the transactional data. So we may also refer them as non-historized satellite tables. And additionally, if the number of attributes to be captured is relatively high, then we can also divide them into the different satellite tables according to the separation rules of the satellites. But there would be times to store attributes that are part of transaction into link table would make sense. For example, if the performance is an important issue, like you are getting a high volume of data from a machine or sensor, then it would make sense to load data directly from source system to target link without changing the granularity of the link. So we don't need to spend time to split source data into satellites and the link tables. But again, keep in mind that the keeping all attributes in link table instead of using satellite is not recommended approach because it increases ETL and maintenance complexity. Therefore, you should really look for a proper and mandatory use case.